Chapter 3 Heat Capacity and Specific Capacity. When we heat a beaker of water, the temperature of the water rises. The temperature of water depends on how much heat that is transferred during heating. In the following experiment, we are going to investigate the relationship between the energy supplied and the temperature rise of the water. Using an immersion heater, we heat a polystyrene cup of water. We have a thermometer to check the temperature. We have the stirrer to stir the water so that the temperature of water will be uniform. We also use a joule meter to measure how much heat energy is transferred by the heater to the water. So we will repeatedly heating the water for 1 minute to see the temperature rise for every 1 minute of heating. And now please pick up a pen and prepare to copy down the experimental result from the video.
Fill 0.2 kg of cold water into a polystyrene cup and place an immersion heater and a thermometer in the cup. Read the initial temperature of the water. Switch on the heater for 1 minute and then switch off. Stir the water and read the highest temperature reached.
Now, first of all, change the unit of time of heating to minute. And after that, add more columns. And I'm going to show you the result very soon. So the time of heating starts from 0, where the heater has not started heating. We have heated for quite a few minutes. And the initial temperature of water was 22, and it keeps rising. Would you copy that down? And don't forget to fill in the last row of temperature rise. Let me do the first 2 for you. And now would you do the rest? And now on the next page, you have to plot a graph of temperature rise in degrees Celsius against time of heating in minutes. And so you should label the axis this way. For temperature rise, it should be 10, 20, 30 degrees Celsius. For time of heating, it starts from 0 up to 6. And after that, plot the data points and then draw a best fit straight line. And so here we go, the data points will look like this, and then we may draw a best fit straight line, and it turns out it also passed through the origin. The notes on the left tell us something important. When we find a straight line that passes through the origin, that means y and x are directly proportional. So in our case, the temperature rise and the time of heating should be directly proportional. There we go. The time of heating also represents the energy supplied, so we may have that result. The energy supply and the time of heating, delta T, are directly proportional. So we may write the equation, which look like this. Q equals C delta T, where C is called heat capacity, and the unit of heat capacity is Joule per degree Celsius. But why? Let me explain it here. The unit of energy, which is Q, should be Joule. The unit of temperature rise should be degree Celsius. In this way, the unit of heat capacity should be Joule per degree Celsius. But what does that mean? Let's take a look at a cup of water. It has a heat capacity of 250 Joule per degree Celsius, and that means it absorbs 250 joules of energy when its temperature rises by 1 degree Celsius. So, if the temperature increases by 2 degrees Celsius, it should absorb altogether 500 joules of energy. That's the meaning of heat capacity in units of Joule per degree Celsius. Now let me explain the checkpoint questions. You can see from above that we use a polystyrene cup with a lid. Why? Foam cup is used because foam or polystyrene is a better heat insulator than glass. It reduces heat loss to the surroundings. Moreover, the heat capacity of a foam cup is also very small, that it absorbs very little heat energy. And for the lid, it is also used to reduce heat loss to the surroundings. Covered by the lid, the hot content of the cup cannot touch the surrounding cold air, so the hot content is insulated from the surrounding cold air. The lid also prevents water vapor to escape with a lot of energy. And what about the stirrer? What it is used for? A stirrer is used to stir the water so that to ensure the temperature of water is uniform, so it would be the same everywhere inside the cup. In this way, the temperature measured by the thermometer will be accurate. When doing this experiment, one of the precautions is to ensure that the heater is totally immersed in water when it is on. Why? Because the heater may overheat easily if it is not totally immersed in water. Moreover, there will be less heat absorbed by the water, and the temperature rise of the water becomes smaller. You may also notice that we measure only the highest temperature reached after the heater is turned off. Why? Because at the time when you turn off the heater is still hotter than the water. So it takes some time so that the heater and the water will have the same temperature. Make sure you copy down all these answers before you go back to the classroom. And before the end of the video, let me show you another experiment about heating of water.
Measure 0.15 kg of cold water in a polystyrene cup using a balance. Note the temperature of water. Switch on the heater and start the stopwatch. Stir the water and record the time taken for the temperature of water to rise by 10 degrees Celsius. Repeat this procedure for 0.2 kg, 0.25 kg, and 0.3 kg of water.
This is the result of the experiment. So, what does it tell us?